Hello everyone and welcome. I'm excited to have you here today. We're going to explore an innovative topic, virtual tables in Dataverse, seamless external data integration. In this presentation, we'll look at how this technology enables real-time connectivity, supports custom providers, and offers advanced data management capabilities. Over the next few slides, we'll dive into the details and see how this can transform your data landscape. So, let's get started. Let's take a closer look at virtual tables in Dataverse. Essentially, they allow you to seamlessly integrate external data sources into your Dataverse environment. The key benefit here is that users can interact with this external data just as if it were native to Dataverse itself. This means a consistent experience across all your applications, making it much easier to work with data without worrying about where it actually resides. Another important point is that this approach eliminates the need to duplicate or replicate data. Instead, virtual tables provide real-time connectivity, so you always have access to the most current information. This is especially useful for scenarios where data changes frequently or needs to be accessed instantly. And how does this work? Well, virtual tables bind directly to external data sources, creating a seamless connection. This way, your applications can interact with external data as if it were part of Dataverse, ensuring smooth integration and reliable data access. Overall, virtual tables make external data feel native, supporting a more unified and efficient data management experience. Let's take a closer look at the session agenda. Today, we'll focus on virtual tables in Dataverse and how they enable seamless external data integration. On this slide, you'll see the main topics we'll cover. First, we'll explore the out-of-the-box capabilities and advanced customization options, which are key to tailoring virtual tables to your needs. Next, we'll examine a practical example scenario using virtual health data tables to see how this works in real-world applications. Then, we'll move on to a demo and code review of virtual table providers in action, giving you a hands-on look at how these components operate. We'll also discuss the key considerations and challenges you might face when implementing virtual tables, so you're prepared for potential hurdles. Finally, we'll talk about when and why you might want to build custom providers for virtual tables, which can give you even greater flexibility. Overall, this session aims to give you a solid understanding of the core concepts behind virtual tables and how they can enhance your data integration strategies. Now, let's take a closer look at Dataverse virtual data tables. These virtual tables allow us to seamlessly connect with external data sources, enabling real-time data integration without the need to duplicate or import data into Dataverse itself. They are a powerful feature because they let us work with external systems as if they were part of our Dataverse environment. However, it's important to note that virtual tables don't yet offer all the capabilities of standard Dataverse tables. There are some limitations, so while they are great for integration, they might not support every feature we use with regular tables. One of the key advantages of virtual tables is their support for real-time data access and updates. This means whenever data changes in the external system, those changes are reflected immediately, ensuring our data is always current without manual refreshes. Supported external providers include several popular options. For example, we can connect via OData v4 endpoints, which are widely used for web services. We can also connect to Azure Cosmos DB, a scalable NoSQL database in the cloud. Additionally, virtual tables support virtual connections to SQL Server and Microsoft SharePoint, broadening our integration capabilities. And for organizations leveraging Microsoft Fabric, virtual tables integrate smoothly to bring data from those sources as well. One of the standout features is that Dataverse virtual tables connect directly to these external systems. This means they don't store a copy of the data locally, which can save on storage and simplify data management. Instead, they act as a live link, providing real-time access without the need for data duplication. So overall, virtual tables are a flexible, efficient way to extend our data environment, connecting seamlessly and maintaining data freshness across multiple external sources. Let's take a closer look at the key concepts of virtual data tables. Specifically, in Slide 5, we focus on virtual tables in Dataverse and how they enable seamless external data integration. One of the biggest advantages is that you can leverage the existing Dataverse user interface and security models. This means you don't have to learn a whole new system or compromise on security when connecting to external data sources. By using this approach, it simplifies the entire integration process and helps reduce the overhead associated with managing data. That's a huge benefit because it allows you to focus more on your core business logic rather than dealing with complex data management tasks. Another important point is the simplification of integration. Virtual tables provide real-time data access, which means you don't have to worry about delays caused by data replication. You get up-to-date information instantly, which is critical for many business scenarios. And perhaps most importantly, the user experience remains largely unchanged. When working with virtual tables inside Dataverse model-driven apps, users won't notice any difference. They interact with data just as they normally would, making this a very smooth and intuitive solution. So overall, virtual tables help you integrate external data seamlessly, efficiently, and securely, all while maintaining a familiar user experience. Now, let's take a closer look at the advanced features of virtual tables in Dataverse. One key point is that using non-GUID identifiers allows for seamless matching with external data keys. This means you can easily connect your Dataverse data with external systems without complicated mapping. Next, we have custom authentication mechanisms. These are crucial because they ensure secure access to external systems, giving you peace of mind that your data remains protected during integration. Another important aspect is the support for various integration workflows through event support. This enables your apps to react dynamically to changes and triggers from external sources, making your integrations more flexible and powerful. Supported operations include retrieving data, both single and multiple records, as well as creating, updating, and deleting data. This full range of operations makes virtual tables a versatile tool for managing external data seamlessly within your applications. Finally, data aggregation capabilities allow you to combine data from both Dataverse and remote sources within a single app. This provides a unified view, simplifying data analysis and decision-making processes. Overall, these features give you full control over external system data and behavior, making virtual tables a robust solution for integrating and managing data across multiple sources efficiently and securely. Let's take a closer look at virtual tables in Dataverse and how custom providers enable seamless external data integration. Custom providers give businesses the ability to have full control over their data operations and connectivity. This means you're not limited by predefined options. Instead, you can tailor the data handling to meet your specific needs. By extending virtual tables capabilities, custom providers allow you to handle things like non-standard identifiers or authentication methods that aren't supported out of the box. They also make it possible to implement more complex data aggregation or transformation logic, giving you the flexibility to process data exactly as your business requires. The main reason to build your own provider is that out-of-the-box solutions might not always fit every unique integration scenario. Sometimes, your requirements are so specific that creating a custom provider becomes the best way to ensure your data operations are efficient and reliable. So, in essence, custom providers empower you to go beyond standard options, giving you full control and flexibility to connect and manage external data in a way that truly supports your business goals. Let's take a closer look at custom provider components, specifically the data source. This is where the configuration parameters come into play, and these are essential for establishing connectivity between Dataverse and your external data sources. Think of these parameters as the instructions that tell your system how to connect and communicate effectively. Managing the link to remote data is a key function here. It ensures that the connection remains stable and reliable, allowing seamless data access. Authentication is another critical aspect. It involves handling credentials or tokens that verify your identity and keep the data secure. Without proper authentication, your connection wouldn't be safe or authorized. Service endpoints and URLs are also part of this configuration. They define the specific addresses or locations of the external services you're connecting to. These endpoints act like the addresses on a mailing label, directing your requests to the right destination. Finally, the data source component itself encapsulates all these details. It's responsible for defining how the connection to the external service is made. And just to connect everything, this component is bound directly to the virtual table definition, ensuring that your external data appears seamlessly within Dataverse, maintaining the overall theme of smooth external data integration. Now, let's dive into the role of plugins within Dataverse, especially when it comes to seamless external data integration. Plugins are essentially pieces of code that interact directly with external systems, and they play a crucial role in enforcing business rules. Think of them as the connectors that ensure data flows correctly and that the logic remains consistent across systems. When it comes to data queries, plugins handle retrieve and retrieve multiple operations, enabling us to fetch data efficiently. For data manipulation, they manage create, update, and delete actions, making sure that changes are applied correctly and in accordance with our rules. Key plugin types are responsible for implementing these core data operations. They are registered within the Dataverse execution pipeline, meaning they run at specific points during data processing to ensure everything functions smoothly. At the heart of this setup are custom provider components, which are essentially plugins that extend and customize how Dataverse interacts with external systems. They provide the flexibility we need to tailor integrations precisely to our business requirements, making sure everything works harmoniously within the overall architecture. Now, let's talk about how virtual tables in Dataverse support seamless external data integration. On this slide, we're focusing on the key components that make this possible, specifically the separation of data service and data service factory. This separation is crucial because it really supports scalability. By decoupling these elements, we can handle growth more efficiently without affecting the overall system. It also makes the provider code much easier to maintain, since each part has a clear, focused responsibility. Moving on to the next point, Data Service Factory plays a vital role by creating instances of data service whenever they're needed. This dynamic creation allows for great flexibility and adaptability in managing services, especially when dealing with varying loads or different external data sources. It ensures that resources are allocated efficiently and only when necessary. Finally, the data service pattern itself helps encapsulate interactions with remote services. This means it manages requests and responses effectively, abstracting the complexities of remote communication. By doing so, it simplifies integration and improves reliability. When you combine these components, custom provider components like Data Service and Data Service Factory, you get a robust, scalable, and maintainable way to connect to external data sources seamlessly within Dataverse. Let's take a closer look at how virtual tables in Dataverse enable seamless external data integration. The key idea here is that these classes provide a powerful abstraction layer, supporting efficient data transformation. This means that integrating external data sources becomes smoother and more streamlined within our system. When we talk about efficient data transformation, we're referring to how these tools simplify converting queries and results into formats that Dataverse can work with easily. This reduces the need for manual coding, which not only saves time, but also minimizes the chances of errors creeping in during the process. A crucial part of this automation is the use of QueryMap and QueryMap Factory. These are SDK helper classes designed specifically to automate the mapping process. They act as bridges, connecting our custom data classes with the Dataverse table schemas in a seamless way. By leveraging these custom provider components, we make the entire data integration process more efficient and reliable, aligning perfectly with our overall goal of creating a flexible and robust system for external data management. Now, let's look at how virtual tables in Dataverse help us achieve seamless external data integration. They play a crucial role in managing state and flow during data operations, ensuring that everything runs smoothly behind the scenes. This setup also enhances the functionality of providers, giving us more control and flexibility. One key pattern here is the Execution Context Factory, which is responsible for creating contexts for plugin operations. This is important because it guarantees a consistent way of handling plugin execution, regardless of the specific operation. It helps maintain stability and predictability across different data processes. The role of the Execution Context Factory is to generate an execution context that wraps all the relevant details needed for plugin execution. This includes input parameters, operation metadata, and other contextual information. By doing this, it ensures that plugins have all the necessary data to run correctly and efficiently. In summary, the custom provider components, like Execution Context and Execution Context Factory, are fundamental. They provide a standardized way to manage and pass context during plugin operations, which ultimately supports more robust and reliable integrations within Dataverse. This approach aligns with our overall goal of creating flexible, scalable, and seamless data solutions. Let's walk through the custom provider flow. When a plugin is triggered by a Dataverse operation, such as a retrieve, it kicks off the process. The plugin then calls the data service to perform remote service calls to external systems. This is where the actual data retrieval happens from outside sources. Once the data is retrieved, the next step is mapping the results back to Dataverse entities using Query Map. This step is crucial because it ensures data consistency, making sure that the external data aligns properly with the Dataverse schema. Meanwhile, to refine what data we get, queries and filters are applied directly to the external data source. This helps us retrieve only the most relevant data, making the process more efficient. All of this ties into the overall theme of seamless external data integration using virtual tables in Dataverse. The flow is designed to be smooth and consistent, connecting external systems with Dataverse effortlessly. Let's take a look at some key limitations and considerations when working with virtual tables in Dataverse. First, you'll need to think about whether your data mapping will be static or if it needs to be flexible and adapt dynamically. Static mappings are straightforward, but if your data sources or requirements change frequently, you'll want to consider dynamic mapping options. Next, security and authentication are crucial. You'll need to plan how to manage access and ensure data is protected, especially if you're connecting to external sources. This involves setting up secure authentication methods and carefully controlling permissions. Performance is another important factor. Debugging issues and maintaining optimal performance can get complex, especially as data volume grows or queries become more intricate. It's essential to understand how these aspects will impact your solution. Handling complex query transformations can also pose challenges. Some queries may require advanced processing, so you'll want to consider how those transformations will be managed effectively. Of course, you should also evaluate whether any limitations of virtual tables could be deal breakers for your specific solution. For example, certain features or operations might not be supported, which could influence your design choices. Finally, check if the remote data source supports the necessary operations and query capabilities. If the source doesn't support what you need, it might limit what you can achieve with virtual tables. All of these considerations are vital to designing a robust, secure, and efficient integration solution in Dataverse. Let's talk about some of the common challenges we face when debugging and testing, especially in the context of virtual tables in Dataverse and external data integration. One key point to keep in mind is that testing connectivity and data transformations separately is crucial. By doing this, we can isolate issues more effectively and ensure each component works as expected before integrating everything together. Next, I want to emphasize the importance of extensive logging. When troubleshooting, logging becomes our best friend. It helps us trace the execution flow step by step, making it easier to identify where things might be going wrong. The more detailed our logs, the better our chances of catching subtle issues early on. And of course, writing comprehensive unit tests is another best practice. These tests validate our logic thoroughly, giving us confidence that our code behaves correctly under various scenarios. Now, when it comes to debugging custom providers, there's an added challenge. Unlike plugins, Dataverse doesn't support a profiler, which makes it harder to diagnose problems directly. This lack of profiler support can make debugging more difficult, but by following these best practices, like thorough testing and logging, we can mitigate some of those difficulties. So, in summary, focus on independent testing, leverage detailed logs, and write solid unit tests. These strategies are essential in overcoming debugging challenges in complex data integration environments. When working with virtual tables in Dataverse, performance considerations are really key to ensure smooth operation. One important tip is to cache data judiciously, but only when it makes sense for your scenario. Caching can significantly reduce latency, but overdoing it or caching outdated data can cause issues. So, always evaluate whether caching is appropriate for your use case. Next, it's crucial to monitor latency and throughput regularly. Keeping an eye on these metrics helps you identify potential bottlenecks early and adjust your strategy accordingly. This ongoing monitoring is essential for maintaining optimal performance. When it comes to monitoring and caching, the goal is to avoid bottlenecks, especially in remote service calls. If your system keeps waiting for slow responses, it can severely impact user experience. So, designing your data retrieval processes to minimize these delays is vital. Optimizing your queries is another critical point. Efficient queries reduce the amount of data transferred over the network, speeding up overall performance. Remember, the less data you need to fetch, the faster your system can respond. Finally, it's important to recognize that performance heavily depends on the responsiveness of your remote data sources. If the source itself is slow or unreliable, it will bottleneck your entire process. So, always consider the capabilities and health of your external data sources as part of your performance strategy. Let's talk about authentication and security in the context of virtual tables in Dataverse. This dual-layer security approach is designed to protect sensitive data while also maintaining trust with your users. It's really about creating a robust security environment that covers multiple aspects. First, ensuring compliance with organizational security policies is crucial. This means implementing security controls that align with your company's standards and regulations, so data remains protected and compliant at all times. Next, it's important to also put access controls on the remote data source itself. By doing this, you're adding another layer of defense, making sure only authorized users and systems can access the data at the source level. Then, we have security roles within Dataverse. Applying these roles helps control who can see or manipulate virtual tables, giving you precise access management tailored to your organization's needs. Finally, storing credentials securely is vital. Using secure vaults or encrypted storage solutions helps prevent unauthorized access to sensitive authentication data, ensuring that your security measures are not just effective, but also resilient. Altogether, these layers work together to create a comprehensive security framework that supports seamless external data integration without compromising safety or trust. Let's take a closer look at static versus dynamic mapping within virtual tables in Dataverse. Static mapping, as the name suggests, works best when you have a fixed schema with predictable data structures. It's straightforward and generally easier to maintain, making it ideal for scenarios where the data format doesn't change often. On the other hand, dynamic mapping is more flexible and supports evolving schemas or variable data structures. This means it can adapt as your data changes over time, which is especially useful when dealing with external data sources that are less predictable. However, it's important to remember that this added flexibility can impact the complexity, maintainability, and performance of the provider. So, when planning your integration approach, you should carefully consider your specific business requirements. If your scenario involves stable, well-defined schemas, static mapping might be the best choice. But if your data sources are more dynamic or subject to change, dynamic mapping could provide the adaptability you need. Just keep in mind the potential trade-offs. Overall, understanding these differences helps ensure you choose the right approach for seamless external data integration. In this section, we're diving into virtual tables in Dataverse and how they enable seamless external data integration. I'll walk you through some practical examples to really illustrate the key concepts and best practices. Throughout the demo, you'll see live demonstrations of how data can be retrieved and manipulated using virtual tables, giving you a clear picture of their capabilities. We'll also look at how custom providers are implemented and registered within the system. This part is crucial because understanding how to extend virtual tables with your own data sources opens up a lot of possibilities. And to give you an even deeper understanding, we'll showcase the actual code behind virtual table providers so you can see how everything comes together technically. The goal here is to connect all these pieces, concepts, best practices, real-world examples, and code, so you can confidently leverage virtual tables in your own projects. This is about making external data integration smoother, more efficient, and more aligned with your business needs. Let's take a closer look at virtual tables in Dataverse and how they enable seamless external data integration. During plugin execution, managing the execution context is crucial, as it allows us to handle data flow effectively and ensure smooth operation. A key aspect here is mapping external data to Dataverse entities, which helps us keep data consistent and accessible within our environment. We'll also explore the query map usage, which is essential for translating queries between systems, making remote calls efficient, and properly handling responses. This process ensures that data retrieved from external sources can be integrated seamlessly into Dataverse. Data service handling plays a vital role as well, especially for retrieve and update operations, allowing us to interact with data in a reliable and standardized way. And finally, the plugin implementations demonstrate how all these components come together in real-world scenarios to enable robust, real-time data integration. Overall, this slide highlights the technical depth behind virtual tables, emphasizing their importance in creating a unified data experience across external and internal systems. Let's take a look at how virtual tables in Dataverse can really enhance your data integration strategies. They allow you to adapt to unique scenarios by extending with custom solutions, giving you the flexibility to tailor integrations to your specific needs. This means you won't be limited by standard options and can craft the perfect connection for your environment. One of the biggest advantages is that you can eliminate the need for complex ETL processes. Instead of building complicated data pipelines, you can enable seamless interaction between Dataverse and external systems directly, simplifying your overall data management. This also translates into real-time interoperability, so your data stays synchronized and up-to-date without delays. Plus, by avoiding data duplication, you can significantly reduce storage expenses, making your data operations more cost-effective. In essence, virtual tables provide a powerful, flexible, and cost-efficient way to integrate external data sources smoothly into your Dataverse environment, aligning perfectly with our goal of creating smarter, more connected solutions. Let's take a closer look at designing with virtual tables in Dataverse. The goal here is to deliver a seamless user experience within our model-driven apps. That means ensuring that interactions feel smooth and intuitive, even when accessing external data sources. To achieve this, it's important to consider a few key factors to avoid potential integration issues. First, think about the capabilities and limitations of your remote data source. This includes understanding what operations are supported, how authentication works, and what performance characteristics you might encounter. These elements can significantly impact how well your app performs and how smoothly users can interact with external data. Another critical point is understanding that virtual tables don't offer full parity with standard Dataverse tables. This can affect the functionality you're used to, so it's essential to recognize these differences early in the design process. And finally, when working with virtual tables, always evaluate the inherent limitations of this technology. Knowing what it can and cannot do helps you design more robust solutions and avoid surprises down the line. Overall, keeping these considerations in mind ensures that your integrations are reliable, efficient, and provide a consistent experience for your users. Now, let's talk about weighing custom provider costs when working with virtual tables in Dataverse. One of the key considerations is performance. Are there any potential bottlenecks that could impact real-time data access? It's important to understand how the remote data source handles query transformations and filtering, because these can significantly affect performance and user experience. Next, we need to consider authentication and credential storage. What mechanisms are available to ensure secure access? And where can we safely store those credentials to prevent unauthorized access? Security is always a top priority. Finally, we should verify whether the remote system supports the necessary CRUD operations: retrieve multiple, create, update, and delete. These are essential for maintaining data consistency and enabling full interaction with external systems. Connecting all these points, it's clear that evaluating these aspects helps us optimize integration, ensure security, and deliver reliable, real-time data access in our solutions. Now, let's consider the balance organizations need to strike between ownership costs and the benefits of tailored data access and integration flexibility. Essentially, while customizing data solutions can offer significant advantages, it also comes with associated costs that must be carefully weighed. Moving on to performance tuning, it's important to recognize that optimizing performance is often necessary to prevent bottlenecks that could slow down your systems. This requires ongoing attention and adjustments to keep everything running smoothly. However, debugging can become quite complex in these scenarios, primarily because there's often a lack of profiler support, which makes identifying issues more challenging. That's why implementing thorough unit testing becomes essential. It helps ensure that your functionality remains intact despite these complexities. When it comes to development effort, building and maintaining plugins and data service factories demands a substantial investment. It's not a set-it-and-forget-it task. Continuous maintenance is needed to keep up with changes in remote data sources and authentication methods, ensuring ongoing compatibility and security. On the upside, if you build a custom virtual table provider, you gain full control over your data integration process. This approach provides maximum flexibility, allowing you to tailor the integration exactly to your needs. Overall, balancing these factors, costs, performance, debugging challenges, and control, is key to implementing effective and sustainable data integration solutions within Dataverse. All right, let's talk about some key takeaways regarding virtual tables in Dataverse, especially when it comes to custom providers. Custom providers are powerful tools that enable us to handle advanced scenarios, but they do require careful thought in their design and implementation. It's not just about plugging in a provider. You need to plan how it fits into your overall architecture. One of the main benefits of custom providers is their ability to seamlessly combine Dataverse data with external data sources within a single app. This means you can create a unified experience for users, integrating different data sets smoothly. It's a real game changer for scenarios where data resides outside of Dataverse, but needs to be accessible within your apps. Custom providers also give us full control over how data is aggregated and transformed. Unlike out-of-the-box solutions, these custom connectors let you decide exactly how data should be processed before it reaches your app, giving you flexibility and precision. Another important point is that custom providers are essential when dealing with non-GUID identifiers or unique authentication schemes that aren't supported out of the box. If your data source uses custom IDs or complex login methods, a custom provider is often necessary to manage those complexities properly. And sometimes, the default providers just don't support your specific data source or requirements. In those cases, building a custom provider isn't just an option. It's a necessity to ensure your solution works exactly as needed. So, in summary, while custom providers open up a lot of possibilities for advanced and seamless data integration, they also require thoughtful planning to implement effectively. When used correctly, they can significantly enhance the power and flexibility of your Dataverse applications. Let's take a closer look at some additional resources that help facilitate seamless data integration with virtual tables in Dataverse. These components work together to ensure that external data sources are integrated smoothly and efficiently. First, we have the integration overview, which involves wrapping the plugin execution context. This step is crucial because it helps maintain consistent processing across different data operations. Think of it as the foundation that keeps everything running smoothly. Next, the Execution Context Factory and ExecutionContext are responsible for mapping queries between Dataverse and the external data model. This means that when a query is made, these components translate it into a format that the external system understands, and vice versa. It's like having a translator that ensures both systems are on the same page. Then, we have the Query Map Factory and Query Map, which handle communication with the external service. These components make sure that data queries are sent correctly and responses are received properly, enabling reliable data exchange. The Data Service Factory and Data Service come into play by implementing core operations such as retrieve multiple, create, update, and delete. These are the standard data actions that applications perform, and these components ensure they are executed correctly against the external data source. Additionally, registering execution pipeline events is important because it allows us to hook into different stages of data processing, providing opportunities to customize or extend functionality as needed. Moving on, the plugins component defines the connectivity details and binds the external data source to the virtual table. This connection is essential for establishing and maintaining the link between Dataverse and the external system. Overall, these components form a comprehensive framework that enables seamless integration, making external data appear native within Dataverse. This integration aligns perfectly with our overall goal of creating connected, efficient, and flexible data environments. Now, let's look at this example of virtual health data tables. What we're seeing here is how virtual tables in Dataverse enable seamless integration with external data sources. The key idea is that once the data is accessed, the results are mapped back to Dataverse entities. This means that the data can be consumed directly within our apps without needing to copy or move it around. Next, the process involves mapping external data to entities, which ensures that the data fits the schema we're working with. Queries are then transformed and filtered as needed, so they align perfectly with the external data structure. This step is crucial for maintaining data consistency and relevance. When a user or application makes a request, the provider calls the external data source using specific service connectivity details. This is what's called a data service remote call, allowing us to fetch the latest data directly from the source. Finally, behind the scenes, Dataverse triggers plugin events for data operations. This means that any necessary automation or additional processing can happen in response to the data being accessed or modified. Overall, this slide illustrates how virtual tables create a smooth, integrated experience, connecting external data sources with Dataverse in a way that is both efficient and transparent for users and developers alike.